Electrostatic force. Electrostatic force experienced by a point charge. Electrostatic force experienced by a point charge due to a linear charge distribution. Due to a linear charge distribution. In the diagram, this is a line. This is a curved line. This is a curved line, xy. Xy be the curved line along which positive charge is uniformly distributed. Along which positive charge is distributed. AC is a small element on this linear charge at the point O. Plus Q be the charge which is distributed along the line xy. Length of this small element AC is dl. dl is the length of this small element. dl is the length of the small element AC at the point O on the linear charge xy. We consider a point P. We consider a point P at a distance r from the small element AC. From the small element AC. P is a point which is at a distance r from the small element AC of the current linear charge xy. Q naught be a point charge which is placed at the point P, and this point charge Q naught at the point P at a distance r experiences an electrostatic force dF. dF is the electrostatic force experienced by the point charge Q naught at the point P due to the small element AC of charge dq and length dr. Let r be the distance. Let r be the distance of a point P from the small element AC. From the small element AC. From the small element AC of length dl and charge dq. And charge dq of the linear charge distribution xy. The electrostatic force experienced by the point charge Q naught. The electrostatic force experienced by the point charge Q naught at the point P due to small element AC of length dl and charge dq. And charge dq is given by df equal 1 by 4 pi epsilon 0 q naught dq divided by r square. df equal 1 by 4 pi epsilon 0 q naught dq divided by r square. Therefore df equal 1 by 4 pi epsilon 0 q naught lambda dl divided by r square. df equal 1 by 4 pi epsilon 0 q naught lambda dl by r square, where lambda equal dq by dl, charge by length. Lambda equal dq by dl, which is the linear charge density. Of the small element AC, or it is also the linear charge density of the linear charge distribution xy. Lambda is the linear charge density of the small element or the entire charge distribution xy. Entire charge distribution along the line xy. Along the line xy. Therefore, the total electrostatic force experienced by the point charge Q naught, due to the entire charge distribution due to the entire portion of the linear charge distribution along the curved line xy. Entire portion of the linear charge distribution xy is f equal integration df. F equal integration df equal 1 by integration 1 by 4 pi epsilon 0 q naught lambda dl by r square. 1 by 4 pi epsilon 0 q naught integration lambda dl by r square. Therefore, f equal 1 by 4 pi epsilon 0 q naught integration lambda by r square dl, which is the total electrostatic force experienced by the point charge q naught due to the entire portion of the linear charge distribution xy. This is the linear charge distribution. Q naught is the total charge plus q naught is the total charge and lambda is the linear charge density of the line xy. We consider a point P. Q naught is a point charge which is placed at the point P, and F is the total electrostatic force experienced by the charge Q naught due to the linear charge distribution xy. Therefore, vector F or electrostatic force vector experienced by the point charge is F r cap, where r cap is the unit distance vector. Vector r is the distance of the point P from O. R cap is the unit distance vector. Therefore, vector F equal 1 by 4 pi epsilon 0 q naught integration lambda dl by r square r cap. Vector F equal 1 by 4 pi epsilon 0 q naught integration lambda dl by r square r cap, which is the electrostatic force vector, experienced by the point charge q naught at a distance r from the linear charge distribution along the line xy. Therefore, vector F equal 1 by 4 pi epsilon 0 q naught lambda dl by r cube vector r. So this force is expressed in terms of distance vector r. R cap is equal to vector r by mod vector r, which is the unit distance vector, of the point P. Unit distance vector of the distance vector r of the point P from the charge distribution xy. R cap is the unit distance vector of the distance vector of the point charge q naught from the linear charge distribution xy. Additional information with this topic is what? AC is a small element. dl is the length of the small element AC on the linear charge distribution. AC is the small element small element AC of charge dq. dq is the charge contained by the small element AC. And in this case, q naught is a point charge which is placed at P, and q naught experiences an electrostatic force dF along that direction. Again, there is a small charge dq at that position, and dq will apply a force on q naught with a force dF. Similarly, in the lower portion we have a charge dq, and that small charge dq will apply a force dF on the point charge q naught. Therefore, total force on the point charge q naught at the point P is F equal sum of all this forces dF plus dF plus dF dot 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 dot. Therefore, F equal integration dF. Therefore, F equal 1 by 4 pi epsilon 0 q naught integration lambda dl by r square. Therefore, electrostatic force vector experienced by the point charge is 1 by 4 pi epsilon 0 q naught integration lambda dl by r square r cap. R cap is the unit distance vector of the point P from the linear charge distribution. So q naught is experience an electrostatic force vector F along that direction